Okay. Today we do chapter 4, chapter 3. Chapter 3 or chapter 4? Or chapter 3, sorry. Okay, we do chapter 4. Okay, I have distributed the hands out for the lecture. Okay, there are 4 CLO, which is important. This is how we design the test question for your final exam and also your midterm test or your test 1 and test 2. So first, we'll ask you to use equation of motion to analyze rectilinear motion or collinear motion. Second one will be using the second Newton law, which is F equal to ma, to solve the problem. CO3 is what we focus on today. We'll focus on impulse and momentum, right? By deriving from the F equal to ma also. So today we'll focus on CLO3. CLO4 will be on the motion of rigid body. This one focus on the planar kinetics, means on the 2D rigid body. More on the rigid bodies means we chapter 1 until chapter 3 is more on particles. Means we see the body as one object, one big round circle or one dot. But from today onwards, we later will move into rigid body. You will break the object into different bodies. You need to find different CG, and then you use the same approach to solve. Okay, so today we focus on CLO3. Okay, so chapter 4 is about impulse and momentum. So basically, we will learn about the equation of linear motion, impulse and momentum. Then we'll look into angular momentum. Yeah. For this module, we do not go into steady flow of fluid stream. This one will cover in your fluid mechanics 1 with this next semester. Okay, so for dynamic, these two steady flow on a float stream and propulsion with a variable mass, this one is not included in this module. So you will study this one in your next semester module, fluid mechanics 1. Okay, we start with the first equation today with you very familiar equation of motion, F equal to ma. So all the force equal to ma. And then what is the definition of A, acceleration? In chapter 2, when you draw the graph, A equal to what? D what? dV over dt. So we rewrite the A as dV dt. Then this is differentiation. So when we derive, we don't like this kind of form. We will bring the dt to left-hand side. dt to left-hand side means to the f side. Then right-hand side, you have m dv. So you arrive at one integration with look like this form. Okay, so this chapter actually we're recycling F equal to ma, but we are using the definition of acceleration in terms of v. So in chapter 4, you no longer see acceleration anymore. You will see velocity. Okay, so when you have integration of f dt on the left hand side and the right hand side, you have m integrate dv. Since we still in the particle, chapter 4, kinetic of a particle, our mass is constant. So our mass is constant. We pull the mass out from the equation and you do integration. So here, the force also constant. So we pull the T out. Okay, if the force is not constant, then you need to change the F in terms of T. then only you do integration. There are two scenarios. In this case, if you have a constant force, if you have constant force, then you have constant acceleration. So if you don't have constant force, then you cannot use the Newton equation, the 3 Newton equation. Right? Okay, so from here, we just derive the equation. We will arrive at the equation of principle of linear impulse and momentum. F multiply time, we get impulse. Force multiply time, we get impulse. M multiply velocity, we get momentum. mv is momentum. Impulse is ft. So chapter 4, it tells you principle of linear impulse and momentum. So basically, on the left-hand side, you write impulse. On the right-hand side, you write momentum. Derived from F equal to ma equation. Right? In test, we don't test you how to derive, but straight away apply this equation. So when you rearrange the equation, you will get this form. All the force integrate F dt equal to mb2 minus mb1. So this is the form that you have seen similar to the previous chapter. Then from here, so you can stop at this one and name this one as principle of linear impulse and momentum. So if you are given force, you're given time, you're able to find the momentum of the object. You're able to find velocity before and after. Yeah. So here, chapter 4, you only need 4 unknown: force, time, mass, velocity. Okay, basically chapter 4 is only 2 things, which is impulse and momentum. Impulse is force multiply time. Momentum is m multiply v. Okay, and some textbook or later in my slide, I will use capital L to represent momentum. So if it's momentum number 2 or after the incident, I will use L2. If anything that happened before, I will use L1. Okay. Sorry. Okay. So this will be the presentation. If the question forces you to use principle of linear impulse and momentum, the first step is you write this equation. You write this equation and then you look what parameter is missing, you substitute, you find the unknown. Okay, there's no acceleration here, only velocity. Okay, now if you look at the word linear, what does it mean? You know how to plot graph, right? Linear means you have y equal to mx plus c equation. Means either the force is constant or the time is constant. And it moves in the line form. Okay, so it's linear. Okay. Okay, so this is two different cases. What is the difference is on the top is when you have force is non-constant. Then you have a different shape of the force diagram. So area under the graph of force versus time, you get impulse. Then if you have a fixed constant force, you get a square or the rectangular shape of area. So this is just some illustration on what if you have constant force and non-constant force. Right? This is I represent impulse lah. Okay, I represent impulse. So this is what we have seen just now. Ft equal to mv1 minus mv2. So on the left hand side is linear impulse. On the right hand side is momentum. So some textbook they write in this form, which is they want to see the whole equation in positive form. That's why they move the minus mv to the left hand side. They get positive mv1 plus the impulse equal to momentum after. Okay, so these are both are the same. It's only one is all positive terms. One is one side is linear impulse, one side is momentum. It's the same, huh? It's the same. Both also principle of linear impulse and momentum. So MB is momentum at T1 or before. This one, Ft is the impulse, sum of all impulse applied to the object or to the particles. This is the effect after you have the input for your impulse, then you have velocity. Okay, so this basically still the same equation. So if you want to do in the graphical illustration, this is what will happening lah. So this is a particle that have moving in the one direction with the mass, then plus something happen input to the object, then you have the final direction of the vector of the velocity momentum. Okay, so this is the illustration of this equation. Yeah? But of course, this one will come in later. This is when you solve the problems later. Sometimes you need to use this diagram with its initial momentum plus impulse diagram plus final momentum diagram. Okay, and still remind that the V, the F, the V2, they are vector. They are vector. So vector have direction, magnitude and direction. So all the vector, what kind? All any vector that you have, you can split into three directions, which is x, y, and z. So you should know how to break the vector into x, y, and z. So this is an illustration of the this tree is the step of solution. So once you write the equation, then you look at the problems. Once you have the problem, you draw the velocity vector, you draw the force vector, you draw the velocity vector. Then you split the vector into x, y, and z. But usually for this module, I only test you two axes, x and y. Okay. Or if the question is a bit easier, then I give you three direction. But normally I just stop at x and y. Okay. So what is different here is you do the sub x1, sub y1, sub z1 to represent it is x direction, y direction, and z direction. Yeah. So basically, we still at one same equation with its linear impulse and momentum. Yeah. So first step, write the principal linear impulse and momentum equation. Second step, because you are dealing with vector, second step, you break all the vector into x direction, y direction, z direction. Okay. Then you solve. There will be something that you can find in these three equations. Sum will be 0 on the right. Once it's 0, you can find the remaining two. Then you substitute back, solve simultaneous equation. Yeah, it's always repeating this step. First, you write the general equation. Second step, you break into x, y, z. Then there will be one of the equation will equal to 0, or you need to do substitution or solve simultaneous equation. Okay, so this is another, this is for info. If you have individual object inside object, you break into individual small particles. You can write as sum of individual force plus sum of individual mass multiplied by differentiation of individual velocity and time. Okay, but we won't go deep into this one. It's just for info. This for info. This slide is for info. Okay. Okay. So we know that F equal to MA, but we break the A into V dV dt. We move the dt to the left-hand side. So we still arrive at the same equation. But now this one is on the individual object just now. It's the same equation. It's the same equation. It's just that you will see this one again in when we look at rigid body. We are now still at particles. We see everything as one body. Later we look into rigid body, then we break the mass individually. Then you need to add object 1 momentum plus object 2 momentum and so on. Okay, but at this moment you don't need to worry about this one. We worry about this one when it come to maybe chapter 6 later, 5 or 6. Okay, you arrive at the same format. MV1 plus FT equal to MV2. You still get the same equation. So this is for individual particles. Individual particles. Okay. So still the same. Okay, only 4 parameter for chapter 4. Mass, velocity, force, time. 4 things. And then you group before on the left hand side, after on the right hand side. Or if you're lazy, you just put on the left hand side is a linear impulse, right hand side is all the momentum. Momentum number 2 minus momentum number 1. Yeah. So far we're still at the same. So what is a bit different from when you look at rigid body, or you look at a body? So it's on the mass effect. Mass effect give you the center of mass. So mvg will equal to the sum of all the individual momentum, mi v1. Okay. Okay, what is so special about these slides is when the question asks you on the gravitation mass effect. As you can see here, the velocity is actually focused on the G, center of mass, where since chapter 2, when we start to draw the free body diagram, I always ask you to label the center point of the object, and then you draw the W going down. Okay, this is why this diagram is important when you learn about rigid body later. Okay, and just for info, for the velocity that you use in your calculation in particle, as a particle, you're actually focusing on the center of mass. Velocity at the center of mass of that body, before equal to after. Okay. Now we apply what we learned. You have seen this question before in your chapter 2. Okay. So this question you can solve with chapter 1 question, chapter 1 equation, which is you convert this diagram into free body diagram. You are given a mass of 100 kilogram. Original at the rest, you have V1. On the smooth horizontal surface means there's contact force there, normal force. However, friction there's no have. So you still need to find the normal force. And some of you still don't know how to draw normal force. The correct one, normal force is pointing from the surface into the face of the object. Some of you still draw like this. Some of you draw like this. Some of you draw like this. Some without touching the surface, some your arrow touching the top surface. It's a bit different meaning if you draw like this, the bottom two diagram, compared to the first one. If you still draw your normal on the top of the object, in your test later, I'll give you wrong idea. Okay, your normal force actually is the force that what the object feel. The object feels something punching inside the body. It's lying on the floor. So something pointing and not something pulling the object. Okay, although force can be transferable along the line, but when you draw free body diagram, it represent different meaning if you put in the wrong location. Yeah, so it's important. Try not to draw the wrong normal force. So you have a force at 45 degree, apply for 10 seconds. How you know that this is chapter 4 question or chapter 1 or 2 question? You are given time. Chapter 1 do not give you time because it only tests you F equal to MA. And the time you need to find usually in chapter 1 and chapter 2 because you are using the 3 Newton equation. Okay, determine the final velocity and normal force which the surface exerted the crane during this time. So this question force you to draw location of normal force. Okay, so this one I go very fast. So you have seen this one before in chapter 1 and chapter 2. So free body diagram, first you go to the center of the object, draw W, go down. W equal to mg. This one standard already. Go down, then you write W equal to mg, start. Then you copy the force, 45, go up 45. And then there's a normal force there. No friction because the question already mentioned smooth. Sometimes question will give you friction coefficient inside the question just to confuse you. Right. Okay. Then you put in the velocity vector in the free body diagram. So Leslie got asked me this question before. What is the difference between kinematic diagram and kinetic diagram? Right? So kinematic diagram and kinetic diagram. Kinetic diagram, you will see, kinematic, you will see MA, right? Okay. You will see MA in the diagram. Kinetic diagram, you only see V or A inside the diagram. But both, if you give me both answer also correct lah. It's just that there's a difference if you want to go very deep to the term, what is kinematic and what is kinetic, actually the same. So the one that you see on the slide here, this is kinetic diagram. Yeah? So it means you put the velocity along the diagram, along the free body diagram. Free body diagram is only force. Okay. Okay, so you can solve this one by using chapter 1 question, chapter 1 equation with F equal to ma, and also the 3 Newton equation. Why? Because you have a constant force. Constant force gives you constant acceleration. But in this case, we are in chapter 4, so we will force you to use principle of linear impulse and momentum. So the first step, you write the linear impulse and momentum equation, which is mv1 plus mv2 plus mv1 plus force dt equal to mv2, or you can write ft equal to mv2 minus mv1 also can. Then you break into x, y, z position. So we will solve for x first. So what you do, you go back to your free body diagram, convert all the vector into two directions. One is y direction, one is the x direction. Okay, you need to read carefully the question. Some question give you the direction of positive and negative, like what you've seen in your test one. Then you need to follow. Okay, so in this case, our 200 Newton, you can break into X and Y. So if you're still weak in the sine and cos, then you need to work on your mathematics. All right, so this is quite direct, NW. So we're on the X first. So you label to the right is positive for your X. Or you can go to your diagram, you just draw the axis like what you draw in your graph. To the right, X positive, to the Y, go up positive. You can just make a cross there on your answer there, or just beside your object, X positive, Y positive, something like this. Also can, right? So what you do, you just substitute the value inside the principle of linear and moment equation. So mvx1, you know that your v is 0 because it starts from rest. So v0, 0. Okay, you can straight away write an arrow and then put 0 there, x. Then you pull your fx out. Your fx is cos 45. Time is given 10 seconds. Time is given 10 seconds. M you know 100. V2 you don't know. Okay, V2 you don't know. Of course, when it comes to your test 2 or final exam, time will not be given. You need to type part of your exercise or part of your analysis step. You need to find the time. So, right? So if the time is not given, you just maintain the unknown T1, T2 minus T2 minus T1 here in the 10 second there. Then you get equation 1. Then you do for x direction, you get equation 2. Then you solve the unknown. Yeah. So you solve for the Vx2. You do the same for y direction, you will get Vy2. Okay. What is Vy1? Vy1 0, because you start from rest, your V1 is 0. So no matter, there's no vector of your starting velocity. Okay. So the meaning of drawing this one is because you are pulling from the right. So sure the object will move to the right. Okay. So there will be a question asked you what is the direction of the object in your test or final exam. Because you're learning about dynamic, you need to know where does your object going. Right? So you substitute all the value. So V1 is 0, but need to be careful because on the y direction you have 3 forces. You have 3 forces means you have 3 impulse. Each of the force will give you 1 impulse. So you have N will give you impulse, W will give you impulse, 200 y-axis on x-axis, each one will give you 1 impulse. So you have 4 impulse, depending on the axis that you split. X-axis, you have two impulse because of 200 Newton at 45. However, in y direction, you have 4 impulse. Okay, N, W, Fx, and Fy. So sorry, for y you have 3 impulse, not 4. Okay. Okay, so NC multiply time 10 seconds. W is mg. Your m is 100. 10 seconds. And your 200 sine 45, it give you another linear impulse. Okay. So in the test, if the time is not given, you just continue to pull the T2 minus T1 over 10 second bracket here. Then you get equation 1 and equation 2. What do? You just solve, you just eliminate the equation using the equation. But of course, there will be more info given to solve for unknown. Yeah. So here you get NC and not V. Okay, why Vy2 is 0? Why? Why? Why you know Vy2 is 0? What does this meaning Vx2 mean to you? You get full number or you get this equation. Vx2 means it move in the straight line, x direction. So if your velocity already tell you that the velocity move in the x direction, so your y is 0. Okay. Yeah. Because the weight is heavier than the force. The weight, how many? 100 multiply 100 is you get 981 Newton. What is the pulling force? 200. So the object is still stick to the surface. Yeah. So normal force is 840 Newton. Okay, so again now you can solve with the chapter 1, chapter 2 equation, which is F equal to ma, and then use the V equal to VO plus ACT. But this question do not ask you acceleration, it asks you velocity. And also asks you to find normal force. Okay. So the next question, object is going down with velocity 1 meter per second with 30 degree. Mass is given 25 kilogram crane. Act upon a force having a variable magnitude. Your force now is variable, so acceleration is not constant. You cannot use chapter 1 or chapter 2 equation. Okay. Unless you derive, and then you derive from the integration equation. So here, determine the crane velocity 2 seconds after T has been applied. Initial velocity is given, and the coefficient kinetic friction between the crane is given. Mu k is 0.3. So mu k is given means the object moving already. If you're given mu s means the object static. Okay. So the first step always start with the free body diagram and also the kinetic diagram. You want to put in kinematic diagram also can, but again, this is chapter 4. Chapter 4, we do not ask you acceleration. So you put in this one, you will not get full mark for your free body diagram because we are looking for velocity direction. This is chapter 4, a bit different from the previous one. Okay. So I assume you already know how to draw. So you just copy the object, put in the W first, right? 30 degree, normal, friction, the P, right? Okay, and the N normal always 90 degree to the surface, always following the surface. The N always follow the surface, so always 90 degree to the object surface. So friction, once you know the friction, so from today onwards, your answer, if you want to write friction, you write F friction, F sub friction. equal to mu KNC or mu KN. No, we need to write friction. Okay, because F sub K, it will mean something else in this module later on. Yeah? Okay. Okay, once you have that one, you put in kinematic diagram, you put in the velocity, expected direction of the velocity. Okay, now just now I already explained what is kinematic diagram and kinetic. So chapter 1, 2, 3, you use kinematic. Chapter 4 onwards, you will start to use kinetic already. Kinetic diagram means you combine with the free body diagram. Right. Okay. Once you have the diagram, you pull out the principle of linear impulse and momentum. So mv1 plus all sum of the force multiplied time equal to momentum number 2. And you break into x direction, y direction. So in this case, I'm always follow the surface direction. So go down 30 degree, x is positive. And then y going up 30 degree is my y direction. Okay, so my x is go down. My x go down. So let's see if you have able to understand. So mv1, so my v1 is I can use the whole v1x because I follow the surface x direction. Okay, this is why I follow the surface or the motion direction, because I will get full number. I do not need to worry about the sin and cos for my velocity. Okay, and then careless mistake always happen here, which is your linear impulse. Remember, impulse always, if you have one force in the diagram, means you have one linear impulse. You have two, then you have two linear impulse. You have three, then you have three linear, and so on. Anytime you have one force there, you have one linear impulse. So on the diagram, at least you have 3 red arrow and 1 purple arrow. So you have at least four. Linear impulse there. It depends on the direction that you split them later, but at least you have 4 linear momentum, linear impulse. Okay, but in the x, if you look at x, you have the p parallel to the surface, so you need to split your w into x and y. So your x direction, you have p, you have friction, and also w, what? W sine 30. Yeah, so for x direction, you have 3 impulse, p, w in x direction, and friction in here. And one of the careless mistakes, you always forget about the time. You will forget to carry the time every time you link with the angle. Some of you're not able to do this. Some of you're able to split force, but then in your answer, you will forget about the time. Careless mistakes, always I seen in the student work. Okay, here I put in the P there because I don't know the value of P. Because here I given in 100 T, so I just put in the term first, the force first, before because I don't want to confuse myself. I just focus on the forces first because each force gives you impulse. I just want to focus on the force, and then your mvx2. Okay, then only you expand the equation. F friction equal to mu n, and then the P is 100 T. Then you do integration part lah. Okay, then only you substitute the value in the next steps. You put in 25, velocity is 1. Why velocity is positive 1? Because it's along the positive x direction. Here, why positive 1 and not negative? Because your x direction is going down. And normal x direction is going to the right, but this one is going down to the left. That's why your 1 here is positive. If the question in the test force you to use certain direction, this will be the careless mistakes, as what you've seen in your test 1. Okay, the rest I think you're able to do already. Only integration, polish up your integration. 100, if you're not sure, pull the 100 out, and then you do integration of t. You get t squared divided by 2. And there's no constant value because you have the limit. You arrive at the first equation. You arrive at the first equation. 25 plus 200 minus 0.6 normal force plus 265.25 equal to 25 Vx squared. You are dealing with x direction. Equation in x direction first. Okay, here you have 2 unknown, so we need 2 equations. You find the next equation in y direction. So you do the same. In y direction, all the force in y is 0 because the object do not fly up. You don't fly up from the surface, so you know that it's 0. Again, you have to mark your positive direction is actually following the perpendicular direction of 30 degrees here. So you solve by equilibrium equation. So all the y force equal to 0. So NC equal to cos W equals 0. Yeah, again, those that if you don't understand the angle between the force, you just imagine how you tilt the object and then you tie a rope there. Okay, if the object is flat, then you tie a rope, then you tilt the object, you'll see what is the angle between the original perpendicular and the rope. Okay. Yeah. Okay, once you do, you get your NC, you substitute back to the previous equation, you get your Vx2. Okay, so this is a bit tricky part. Every time in chapter 4, you might need to recall equation of equilibrium when you solve. Means you can use all the force in x equals 0 or all the force in y equals 0. In this case, you use all the force in y equals 0 because the object do not fly up from the surface. Okay. Okay, once you have, okay, so you already find your Vx2. Of course, you can find with the chapter 1, chapter 2 equation. This is another set of equation. This one, you no need to copy. It's just to show you if we solve with chapter 1 question. But this question, again, it do not ask you acceleration. So if you still use F equal to ma, you are asking trouble for finding acceleration. You're wasting your time to find acceleration. Okay, so just show you that this is if you use the F equal to ma equation to solve. Again, why this one we stop at Vx2? Why we stop at Vx2 and we do not do Vy2? Yeah, so because your object is following the surface. All right. Okay, we go to the last example for today. So we look at the diagram. So this is a pulley question. Pulley question always need to recall the basic steps. Once you see pulley question, first you find the total length first, equal to LA or L1, L2, same lah. So I just write L1 plus L2. Step 2, you d LT, dt. The LT dt will give you 0. Right, I'll give you 0. This one, the L1 dt will give you V1 plus V2. Move it, so you get these two actually is opposite direction. Again, a negative, it means different direction, is a vector. Then you dt again, you get acceleration. Okay, what need to be careful here is the datum. On the graph here, your datum is as C, as A go down positive, as B go down positive. Okay, you are given block A and B, one with 3 kilogram and 5 kilogram. B is much heavier, so B will go down, A will go up. This is a common sense. It's a common sense. B heavier, go down, A go up. If the system is released from rest, it gives you the first V already. Usually start from rest. Determine the velocity of block B in second. Ignore the mass of the pulley and cord. So you still need to use the pulley equation, and then you need to draw free body diagram. The free body diagram will help you to find the tension of the cable, how many tension that you have. So we start with the free body diagram. We start with pulley number. This is pulley number pulley D. So pulley D, you have one here and then two rope on the top. So you can label as TB or T1, T2, right? So your TA actually is equal to 2 TB, right? This TA equal to this 2. And from the diagram, you can calculate what is the tension cable already because it's just a mass. So when you have mass, you can calculate W, convert mass into force, right? Then from there, you can know what is the tension cable already. So if you draw the A object, your A object, W go down, and you going up is 2 TB. Why we do not use TA? Because we want to eliminate or we want to reduce unknown in our calculation. Then you go to TB. TB, you are having this diagram. So TB, W go down, and then you have 1 TB. Yeah, so this one you focus on the object, and then you imagine yourself you are that object. If you're feeling something, you're tied to something, you try to feel what do you feel if you are that object. If something pulling, then it go up. If something pulling you down, then arrow go down. Okay. So should be no issue here. Okay. Now you look at the question, asks you to find B. If the question asks you find B, you just pull the principle of linear impulse and momentum for that object only. You don't mix everything in one equation. Means that principle of linear momentum, linear impulse and momentum for that object only. Unless it asks you to integrate the whole effect, then you sum all the equation together. Okay. Here I put in the kinetic diagram. I put in the expected velocity direction. So here, why do I put go down positive? This is a Pulley question. Your datum is given. Your datum is given. Your datum go down positive. So that's why your VA in the kinetic diagram, you follow the datum direction. Follow the motion given by the datum. SA go down positive, the arrowhead. That's why your green arrow VA is go down positive. Although you know if you release B, A will go up. You know that if you release B, A will go up. But this is for your analysis based on the diagram with datum. With datum, this is on mathematical analysis for your mathematical analysis, vector analysis. If you write positive means something, negative means something. Yeah. So in this case, you know your VA will be negative. You know if you look at this diagram and the motion, you know that your value of VA later will be negative. Okay. Again, VB, why positive? Because datum go down positive. Okay, then you go for Pulley equation, you find total length. Total length, SB equal to 2SA. So L equal to 2SA plus SB, you do integration. You do differentiation, you get 2VB equal to minus VB, or VB equal to minus 2VA. See, it's the same. Yeah? Right. So once you have the equation from the Pulley equation, then you apply object by object using principle of impulse and momentum. You look at object 1, which is object A. You write mv1 plus ft equal to mv2. And this one, you look at one direction only. So mva1 go down, it release from rest. Before is from rest. On the left hand side is before. So mv1 before from rest 0. And again, ft, this one, linear impulse, you need to be careful. Every time you have one force, you have one impulse. So here you have two forces. You have W and tangent cable. So you have two impulse there. Okay, so 2TB multiply time plus W multiply time. Then 2MVA, you don't know the final velocity. You solve, you get one equation with two unknown. Then you go for B. You do the same. You do the same for B. Same, MV plus FT equal to MV. MV also, MV1 0 because same, release from rest. And in this case also, just be careful on the tension. Right, just now it's 2 TB, now it's only 1 TB. And plus W. Careless mistake is on the direction because go down positive, your TB is negative and not positive. Yeah, careless mistakes. So you solve it, these two equations, solve simultaneous equation. You know how to solve, right? Simultaneous, we want to remove TB. What do? What you do? either multiply this one 2 or you divide 2 lah. It depends lah. Okay. So this one, you homework, you go and solve simultaneous equation. You remove this one, you have 2 equation. Okay. You remove this one, you have actually you have 3 equation here already. You have VA equal to minus VB, one equation from the rope, from the pulley system. Then you have these two. You eliminate TB by you multiply 2, then you minus. Understand? Who don't understand what I'm talking about? This one. You multiply 2, then minus 2 minus you get positive. You eliminate. Yeah. Okay. So we are doing subtraction simultaneous equation. Once you eliminate TB, you arrive at this equation and this the new equation. Substitute, you solve for VA. So VB you get 35, TB you get 19.2. Or you can substitute this one inside here. You can substitute this one here. Substitute VA equal to VB in VB term, and then you solve for VB. So here you have TB and VB. There are many ways of solving. So, but this is mathematics. And VB, point down, positive. TB is 91.2 Newton. Okay. So if you come to test or final exam, the question will continue. Will ask you what is the magnitude of tension cable on object A. So this one you multiply 2. Okay. Next class tomorrow we look at conservation. We stop here.